Howdy folks. So if you're like me and you play flight sims, you've probably tried VR, you've probably tried just a monitor, and then you've ended up settling on a monitor with TrackIR. TrackIR is fantastic because you get the resolution, the full resolution of your monitor, whatever you choose for that to be. You're not limited to what VR technology currently allows for us. Now it's getting a lot better. That being said, I personally like to be able to see all of my gauges and understand and read them clearly, which is still kind of iffy doing VR. So I settled on TrackIR, but having used wireless headsets for a while now, I can't stand having a wire hanging off of the TrackClip Pro. Now, yes, you could go with the hat clip that comes with TrackIR. It works great. I have some weird reflections in the room that I play in that kind of wreak havoc with the reflection off of the three reflectors. Not only that, but as you get certain angles off, either laterally or your yaw or your pitch, the reflectors just don't get picked up as well by the IR camera as these straight emitters do. So what I've done is modded my wireless headset to also power the TrackClip Pro. So I have completely wireless headset for flight sims. It really wasn't that difficult. There were a couple things I had to modify in order to make it work. One was obviously I had to wire power for the LED somehow. This box I'm going to get to in a second, but it is not power. It's not a battery. It's a voltage booster because the battery in the headset is a 1S, probably lithium ion or LiPo pack that's nominally 3.7 volts, 4.2 when it's charged. These are designed for 5 volts, so they're very dim running off of the built-in battery. I haven't modified the clip itself in any way. It's just the clip that comes right with it. It fits really well over top of the headset post. I then just cut the wire that came with it. It had a USB male plug that would plug in, and then it had a female USB plug coming off of it, so you could plug your TrackIR camera in there and not lose a USB port, which is really nice. Good on them for doing that. So I cut that, and then I just had a bunch of JR type servo connectors available. That's what I used. You could really use anything that would be a plug. Servo connectors work really well, and it's what I had, so it's what I went with. And then originally what I did was I just plugged this right into my power lead, and I'll show you this in a minute. And that worked, but you had to be fairly close to the camera for the camera to pick up on the LEDs. And then as the battery drained, the voltage came down, which means the current flowing through this also went down and the brightness diminished. So the camera had a harder and harder time picking up these three LEDs, to the point where I had to get closer. Once this got drained enough, once the headset was drained enough, I had to get closer to the screen for TrackIR to pick up these LEDs, and also if I went off angle, it would lose them, so I wouldn't be able to look off to the side. So what I did was bought a very inexpensive voltage boost converter off of Amazon, catted out a little enclosure for it, and then 3D printed this. Wired some leads on. These are also just JR servo connectors. Wired some leads onto that. Since this is a one-off, I used a prolific amount of hot glue because I didn't feel like designing clips to hold these in properly, and hot glue allows you to rapidly prototype. So hot glued the ever-living crap out of the plugs on the inside of here to make them hold at just the right angle, so I can easily plug this in without having to locate the plug inside, and it doesn't flop around, so this plug is always at the same position. And then built a little profile into the CAD so that it fits around the arm of the headset, and just snaps right on. I could probably have designed this snap a little bit better. It came around farther originally. It was probably 290 degrees wrap. Right now it's 210 degrees. But that snapped off when I was trying to clip it on the first time. So it holds well enough. If it gets loose, I can get a zip tie or tape or something to hold it on better. But I have no need for that now. I don't thrash around these headsets, and this is light enough that little bit, you can't even hear it snap, but it's a little bit of snap that just holds it right on there. So TrackIR, TrackClip Pro to voltage boost converter, so we get our input 3.7 to 4.2 volts, and we boost it up to 5 volts. We have the right voltage and the right brightness on this, and then this is just wired to the battery on the inside. I had originally wanted to see if there's a way that I could wire it up so that when the headset was turned off, the output power here would also be disconnected. This is an incredibly small circuit board, and I had just bought this headset, so I didn't want to permanently ruin it. So rather than trying to find some test lead that they had built onto the board that was on when the switch was on and off when the switch was off, and also had enough current carrying capability so I didn't burn up some components in here, instead I just wired this straight to the battery. And I'll go ahead and show you that. The downside of the way I wired this to where it's straight to the battery is if you don't unplug the TrackClip Pro, then the LEDs stay on. Not really a big deal because this has a charging dock, so whenever I'm not using it, I'm sitting it on the charging dock and it will keep the batteries topped off. Plus, the current draw on these total is 16 milliamps. So it's going to take a really long time to drain this battery completely. I think it's somewhere around 700 milliamp hour battery. I don't remember exactly. All right, all 4 screws are loose. And now this just lifts out. You have to be real careful with the Astro A50. This speaker connection is soldered onto both ends. There's no plug, so you can't put too much strain on it. Here we have the hole coming in for the connection. I had originally made this hole really big because I wanted to try to keep this plug in here so you wouldn't see any wires sticking out, and that would allow you to then take this side of the plug and feed it into the hole under here. There wasn't enough room between the speaker driver and the battery housing here to hold that, so I ended up just feeding the wire through, and then I had a big hole that I just took a bunch of hot glue and filled in with, and it looks kind of hokey, but it works, and that's all I really care about. So then I just routed the wires around the outside, around the periphery. There was enough space there. There are 3 connections on the main board here. This is ground. This is your from the battery. So this battery is actually wired straight onto this board here. I'm not sure if this board is acting as the battery controller or if there is something on the underside that is the battery controller, because at one point I overheated the board, I think, when I was soldering it, because I messed up and I had to take some connections off and put them back on. And the output voltage of the battery was only 0.5 volt. And I thought I had fried the entire thing. Turns out I just plugged in the USB charging cable and it reset itself and it worked great. So, not quite sure what's going on there. Some sort of over temperature protection. Either the board is doing it, which I'm not quite sure how it would be since I soldered straight onto what I think are the battery connections. So no matter what the board's doing, the battery should still be putting out 3 point something 4 volts. So there's got to be some sort of battery controller under this, another board that I just don't see. I didn't want to tear this apart anymore. So battery 3.7 to 4.2 volts coming out, depending on charge, coming into our plug. Then we've got a $1.15, $1.20-ish. I don't know if you can buy just one. I bought 10 on Amazon for $10 or $11. Just a voltage boost converter. You put in 2 to 28 volts, I think, and it puts out 4 to 30 volts or something like that, and you just adjust it with this potentiometer. So that is in here. Going this way. So we plug this in, voltage comes in. Nope, sorry, this way. This is wired up to here, voltage comes in, we boost it up to 5 volts, and then we come out and plug in our TrackClip Pro. If you have any questions, please feel free to drop a comment. I'll see if I can answer as best I can. This voids all of your warranties on your headset and your TrackClip Pro, so take this project on at your own risk. If you break it, you're probably not gonna get it fixed. Thanks for watching.